Hey everybody, my name is Rodrigo. I work for Conditional 42 in Brazil, and I'm gonna talk about the Rust ownership and borrowing system. You can find me on social medias at Boniatti Rodrigo. So what is the ownership? The ownership is the Rust central feature. So if you have never worked with Rust before, you might came across with different kind of issues that you probably never see in other languages because of the syntax of Rust can be some kind different for newcomers for the language. The goal of the ownership is for memory management, is a different way that I have never seen other language before that I'm used to do. And I'm gonna talk about that a bit later. And it's pretty important that you understand the difference between the stack and the heap in the memory, because the ownership is focused on to solve the memory allocation on the heap. And I'm gonna do a quick recap about those, but it's pretty important that you deeply understand the difference between them. So let's do a quick recap about memory management on the some programming languages. So we have language which do a manual allocation, like C, where you have functions like malloc and free. And the good part of that you have entire control of the memory in your application. But the problem that is that it's a bit hard to scale, it's a bit hard to maintain, and that can cause some troubles in your program. And languages like Ruby, Python, JavaScript, we have a garbage collector, which basically it does everything for you, so you don't need to care about memory. The problem with it is that we have a process running background in your program, and it consumes more memory and can make your program run a bit slower. So Rust came up with the ownership to solve this problem. And for the ownership, there are three main rules that you need to follow. So instead of having a garbage collector, which Rust doesn't have a garbage collector, instead of manual allocating or deallocating, we have the ownership. So there are some rules, and the three main rules are each value in Rust has a variable that's called its owner. There can only be one owner at a time, and when the owner goes out of the scope, the value will be dropped. So I will come back to this slide as we move forward on the explanation. So let's first see some examples of the Rust. So here I have a pretty simple example. It's just a function where we have the name, which receive my name, and here we are printing my name is, in this case, Rodrigo. And just for you guys know that when you have an exclamation point at the end of a function is a macro. So this function is a bit different than normal functions that you might see on Rust. So let's try to compile it. So for compiling, we're gonna use the Rust C, and I'm gonna pass the first example. And compile it. So I'm gonna try to run it, and it works. Also, those as examples that I'm showing here is most of them you can find on the Rust documentation. So here I'm trying just to run them and to try to explain a different way. Okay, so the example one runs fine. So let's see a second example. So in this second example, we have a pretty similar example. We have the name, which receives Rodrigo, and now we have my name, which receives name. And here we are trying to print name. Let's see how that goes. So trying to compile the example 2. So here we have a warning saying that unused variable my name. That's okay because we are not using my name here. And let's try to run the compile file of it. So it works. So My name is Rodrigo. Fine. So let's go to the third example here. Things start to be a bit interesting. So I have my name, which receives string from Rodrigo. And the same thing, my name received name, and we try to print it. Let's see what happens when you try to compile it. So here we have an error. The error says borrow of moved value name. And also there's this, for me, is the important error that we have here, value moved here. So what's happening here? So there's a different, the first thing that we should know that here we use a little string. A little string is saved on the stack of the memory. And here we are using the string from, which are saved in the heap. So the main difference between those, that we save things on the heap that we don't know the size at compile time. And we put things on the stack when we know the size of compile time. So this string from, actually, we can increment and decrement things on this string. So the program doesn't know how much space it should use for this string. So we save this value on the heap. So, and when we move, on this example, when my name receives name, it does a copy. So it copy the value of name to my name. Is actually is what we call like a deep copy. It copied the entire string to my name. It's not a reference. It's not a shallow copy. It's a copy of the entire string. So in this case, we have two variables with my name on the stack. And here, Rust. So Rust has a different approach for that. It's not a copy. So as I said on this slide, let me go back to the rules here. Each value in Rust has a variable that's called its owner. There can be one owner at a time. When the owner goes out of scope, the value will be dropped. So each variable on Rust has an owner. So the owner of the string from here is name. When my name receives name, it takes the ownership of name, and name doesn't have any owner when that happens. So here we call a move. We are moving the ownership of name to my name. And when these lines reach, we don't have ownership for name. So in this case, as the last rule say, when our owner goes out of scope, the value will drop. So when we move the ownership to my name, lost the ownership and it's dropped off the memory. So name doesn't exist here. So that's why we have the error here, value moved here. And there's a second error which is important to look, is move occurs because name has a type string which does not implement the copy trait. So in Rust we have traits, which is kind of similar with interface in Java, and a little string has the copy trait where we do a copy here, but the string from doesn't have a copy, so we cannot copy the value to my name. Let's go to another example here and how we can solve this problem that we saw on the example 3. So the same thing, name receive a string from, and here we try to clone the name. So clone, we are doing a deep clone of the name here. So in this case, name, which will receive this string from, and my name will receive the return of this clone, which will be exactly the string from. That's not so good approach because we're gonna have two same variables on the heap with the same thing, and we don't want to save a bunch of duplicated values on our memory. So what is the best way to solve this issue? So my name can borrow the ownership of name. So in this case, we have name, same thing, a string from, and my name borrows the value of name. For doing that, we need to use ampersand here. So this ampersand returns a reference of name to my name. So in this case, we are not taking the ownership, we're just borrowing it from name. So when we try to run this example 5 here, let me compile it. Have the same warning, but that's okay. We are not using my name here. And if I try to run the compile of it, it works. So let's go to another example here, which make things clear. So here we have name, same thing, string from Rodrigo, and we pass the name to a function called takes ownership. And here we have a literal value of age, which passes to a function called makes copy. So let's see this first example here. So when we pass the name to takes ownership function, we are moving the ownership of name to this one. And if I try to print a line here, like name, let me try to compile this one. So we got the same error that we had before. So here saying value moved here. So the value was moved here. And here saying that the value borrowed here after move. So we are trying to borrow after moving that value. So that doesn't work for Rust. So as we saw on this rule, when the owner goes off the scope, the value will be dropped. So the ownership works by scope. So we have a scope of this function here, and we pass the name to this function. And in this case, this function gonna take the ownership of this value here. And when the function is over, the scope is over, and name does not exist more, the value is dropped from the memory. So we cannot use name at all here. How can solve that? The function can borrow the value. So let's try to run that. Let's see what's going to happen. So now we have a new error saying that we are expecting a string but found like a reference of string. So to solve that, our function needs to expect a reference here. So we can put a reference here on our function, and that should work. Okay, we were able to compile it. Let's try to run it. Okay, it works. It prints twice the name here, from here, and from here. And how about this line? So as I said before, for literal values like numbers, literal string for arrays in Rust, it makes a copy. It doesn't save on the heap, save on the stack. So here, when I pass age to makes copy function, is making a copy. So for this case, I don't need to borrow the age because it's saved on the stack, and we copy the value. So if I try to compile it, works, and if I try to run it, it also works. So you don't need to care about borrowing the value here. Let's move to the example 7 here. So this is a bit more complicated. So we have a string from called hello, the s variable, and we are passing this variable to a function called change. So change receives some string, which a reference of a string, and here we call the push str function, which we are appending an extra string to our string. So here we are mutating, we are changing our string. So let's try to run this example. So here we got a different error saying that some string is a reference, so the data is reference, cannot be borrowed as mutable. So by default, our variable in Rust are mutable. Immutable. Our variables are immutable. So if we want to mute some variable, we need to add the mute in the front of variable. And on this case, we also need to put a reference, a mute reference. And in our function, we also need to expect a mute reference. So if you try to compile the example 7, and now if we try to run it, we have the hello world here. So we can see that we mutate inside here, and you can print the muted version over here. Now let's go to example 8. So the example 8, we have the hello variable, sorry, the hello string, and we pass to the s variable, which is a mutable variable. Let's try to compile it. So it's another rule of Rust that's saying that second mutable borrow occurs here. And there's another message saying that first mutable borrow occurs here. So Rust doesn't allow us to have two mutable variables at the same scope. So how we can solve that? There are some ways. So why Rust does that? Because he does that is to avoid race conditional when two parts of the code are trying to mutate the same value. So Rust tried to create this kind of protection to avoid changing two parts of the code changing the same variable. So to solve that, we can wrap a mutable variable inside a scope. So I can try to first print the R1 here, and at the borrow, I can print the R2. Let's see if that works. It compiled. Let's try to run it. It worked. So here what I did, I create a new scope for R1. And as we saw on the rules, when the owner goes off the scope, the value will be dropped. So here is a different scope. And when this scope is over, this variable, all of this variable is over, everything is dropped from the memory. And R2 can work because there's just one mutable reference on this scope. And we have another mutable reference on this scope. So let's look the last example, the example 9. So here we have like a mutable reference of S, and R1 is borrowing the S, but not like mutable, it's like immutable. And R2 is also borrowing as immutable reference. And here we have a mutable reference of S for R3. So let's try to run it. So here we have a new kind of error saying that mutable borrow occurs here, saying that we have a mutable borrow here, and saying that immutable borrow later use here. So what we are doing here? Here we have like a mutable reference, but we have some reference like immutable before. So for that, Rust doesn't allow us because we can change here, and that can implies over those two variables here. So a way to solve that, I believe, if I put here, we're gonna solve that. Let me try that. Oh, right. So for here, I need to wrap as I did before. I need to wrap in a scope here. So if I wrap inside a scope as I did before, and I just print R3 here, and here just R1 and R2. So it compiled. And if I try to run it, it worked. So we need to, Working with Rust, we need to be sure about the scope, where the variable is defined. We need to make sure that when the scope is over, everything inside scope will be dropped off the memory. We need to make sure that we don't have two mutable reference in the same scope. We need to understand the difference between stack and the heap and how these values are saved. And so if you start to program, do some programs in Rust, you might see these errors. When I start to learn Rust, I saw these errors, and they were new to me. They are kind of different. I have never seen other languages before. So Rust have a very good documentation, so you can look to it, and you can find more examples there. So for my talk, I think I'm over here. So that's all. So if you have any questions, you can leave in the comments on YouTube. I can look later. And you can follow the CodeMiner channel on YouTube to keep receiving new videos like this one. That's all, guys. Thank you. Bye.